Alright guys, anybody have any questions from homework? If you do, you have the floor. Yes, sir. Let's see. Do I have a homework sheet here? I mean, our next test, I gave all my homework sheets away. It's on your homework sheet. Anybody have that? What's the next test?
March test for 3 and 4, March 9th.
No. That's already passed.
April 19th.
All right, April
19th.
All right, we got some time. Hey, we just had it test. Next week is spring break, so pick it back up. All right, if there's no questions from homework.
Can we do 5-3?
We're going to lecture on that today.
Okay.
Yeah, hold on to that and then ask me here in a little bit. Okay.
Oh, yeah.
Oh.
So 79 and 5-1.
5-1. Oh yeah. All right. What's the area of a circle?
5 squared.
Yeah. And so the circle they give you is this. They give you this. Right. So what's the radius? What's r?
3x squared.
Yeah. Yeah. And then you just plug it in. You know that the radius is 3x squared.
Right.
So take that.
So it'd be like 9.
Yeah, so the area equals pi.
Okay.
Replace r with what it is. Yeah, cool. All right. Anything else from homework?
That's 5-2, 7.
What's that? Oh, you have a question 5-2, number 70?
No, what is that?
Oh, this is 5-1, number 79.
5-1.
Yeah. Kiani? Right?
See that?
So how do you do this part here? How do you do this? The pi is just sitting there, right? Sort of like a -2 in that problem from yesterday. Just sitting in front of all that stuff to the 10th power. I don't know if you remember. So that pi is just sitting there. How do you do this?
You multiply 3 by 2.
No. 3 by 2, no.
Yeah. 9.
You multiply 3 by 3.
4. 9x 4.
So 3 squared is 9. X squared squared.
4.
Yeah.
Yeah.
And now you can just put 9 pi and just put it together.
Can we leave it like that, or we should?
No, not really. 9 pi.
Oh, okay. I mean, we don't have to solve it by.
Well, no, yeah. Just leave pi as pi. It's better that way.
You remember 80? I got 14y5. 14y.
Sure.
14y5?
Yeah.
Yep. You got a question?
Yeah.
Okay. Holy crap, there's a lot of people now. Just a few that are comfortable enough to be up close to me. That's going all right.
On 5-2, number 72. Just didn't know what to do it or set it. Is it set up for you?
Yeah.
Yeah. Okay.
Um,
Kind of like
See, the part A is easy, right? You go look at 1990, just look at where the graph is. They give you the graph.
Yeah.
Yeah.
But okay.
So-
okay. That's fine. I just looked at it and I was like, it's an estimate because it's not necessarily.
Totally. I mean, your part A. Let's look at this thing real quick.
5-2.
While that's warming up, any other questions from homework?
Number 24 on 5-2. Is it?
So, this is not complete, but a really quick check if something's a polynomial. Does anybody remember what it takes to be a polynomial?
More than one term.
Two or more terms.
Nope. You can be a monomial.
Oh, yeah.
What does it take to be a type of polynomial? So a monomial is a type of polynomial. What does it take to be a polynomial?
Whole number.
More than one term.
No. All right, let me see. A monomial is a type of polynomial. It's a specific type, right? So it's, don't focus too much on thinking as many terms. I need more specifics. Is this a polynomial here?
No.
No. Okay. Okay. So what does it take to be a polynomial?
No division. No.
No.
Oh,
This
one
is
half.
not. This is all day long. That's a polynomial all day long. Nope. Okay, good. Yeah, I heard. So whole number exponents. What the hell does that mean? You can't have negative exponents. What do negative exponents do? It puts variables on the bottom. So a very quick way to say that, which won't be exactly complete, but it's a really good quick check. You can't have any variables on the bottom, because then there might be some values that I can't use. So here I can't let x be 0, right?
Yeah.
So polynomials, I want them to find everywhere. I want them to look really nice. When I say nice, I want them to be really smooth. Something like that goes to infinity, that ain't nice, right? So a really quick check, which is not a complete definition, but a polynomial, you can't have any variables on the bottom, because you want them to be defined everywhere. Does that kind of make sense? If I have this, can x be anything I want it to be?
No.
What can x not be?
0. Less than.
It can be 0 all day long.
It can't be less than 0.
Totally can't be, of course. What can you not divide by? 0. You can't divide by 0. But what would x have to be to make this 0 on the bottom?
1.
1. Okay, good. So there is a value of x that I cannot use. That's not a polynomial. So
Gotcha.
a real quick check, and again, it's not complete, because it's really, the whole thing is you got to have whole number exponents. So fractional powers don't work. But a real quick check is there can't be any variables on the bottom. So this number 24, it says 5 over xy plus 1. Is that a polynomial? No. I like it. Anything that makes this negative 1 would make the bottom 0. That's no good. So that's why we came up with that word polynomial. If I say I got a polynomial, then I know it looks something like that, and it works. I can plug any value I want in. It'll work for everything. So it can't be this, because I can't plug anything I want in for that. Here's the other question. (72) in section 5.2. I can't kill my poor book. Alright, so they give you a function. Do you see that yummy looking function? 0.163x squared. Yes, yes? Alright, and they graph part of the function, because hopefully some of you guys know that should look like a parabola, because it's got an x squared term. Is that cool? We've talked about that kind of thing before. We actually graphed one, if I remember correctly. So anything with an x squared looks like that. It's not a straight line because it's got a power higher than 1. It's not linear. So they only graph part of it because it goes that, so they graphed part of it for 87s, for I guess 86 and up. blah, blah, blah. So then they ask you, use the graph to estimate 1990.
Okay.
So how many million cell phone subscribers were there in 1990 when the phones were like this? Dude, guess where I'm calling you from? Hello? Yeah, I'd say 3.5 million. Right, it's not 35, 3.5 million. Is that cool? So that was nice.
I read this question.
Don't worry. I think this. I know people will have questions on this one. The rest of the problem's up here. Use the polynomial to estimate the number of cell phone subscribers in 1990. Look, there's the answer. How is x defined? How is x defined? Here they finally defined x really well.
This is days.
X equals 1 means 1986. X equals 2 means 1987. So x seems to be the number of years since 1985. Does that make sense? 1986 is 1 year away. So for 1990, what value would x have? 5. Don't put 1990 into that equation,
That's why I was like, that's where I got.
because that would be the year 3,800 something. And we probably won't have cell phones. We probably have something else you don't even realize right now. We'll have it built into our elbows. Okay, is that cool? So for part B, you plug in 5, because it's been 5 years since 85 for 1990. You plug 5 into that equation, and you should come close to the 3.5 million we estimated. That's an estimate, because there's no way I could be perfect with just looking at it. That looks to be about halfway.
3.6 ish.
Yeah, okay, cool. So estimate,
I got 4.207.
when you plugged it in,
Yeah.
something went wrong. It should come out to be 3.55. You can tell from the graph, it's definitely not going to be more than 4. It's not even at 4.
Yeah, I put 3.6 ish.
Yeah. So the formula should come out to something close to that. It has to, because that's the graph of the formula. So double check your.
Can you do that? Because I have 1.63x squared minus 1.4x plus 0.205.
That's what the equation is. And what are you plugging in for x?
Then I have 0.163 parentheses in the parentheses is 5 above the parentheses is squared.
Yes. So just plug a 5 in for x, and now it's just, can you plug that into your calculator? That's all that is. I mean,
My
you just-
calculator busted. I don't know what happened. I got it on a wrong calculation or something. But,
Calculators are sort of like air conditioners. They either are working or they're not. Even if the battery's low, it can't give you the wrong answer. It'll just go blank. So something went wrong with the way that was plugged in.
Oh.
So you did the right idea, you just didn't plug it in the calculator.
I messed up my contraction.
Okay. All right. I like. Cool. Anything else from homework?
Yeah, it's 3.5.
Yes. Okay. So I'll take that as a note. We're going to get into multiplication, which kind of makes sense. We talked about what the hell polynomials are. We've talked about how to add and subtract them. The next thing we're going to talk about is multiplying, and then after that, we're probably going to talk about how to divide them. It's crazy how that works. So you see, how many of you guys already know? I think I've said this earlier this semester. How many of you guys already know how to do this here? What does that say to do? What's the operation up there? Multiplication. I like it. So whatever x plus 3 is, I want to multiply it by x minus 7. Yeah, there's a mnemonic device, which is fine for you to know. I just wish we didn't teach it. Why not? Because what if I put 3 terms in this bad boy? FOIL don't work no more. It'd be full. I don't know what the hell it would be. I don't think students don't trust me when I say, like, don't take that away from me. But there's a better way to teach. But if you know FOIL, great. It's going to work for you. You just got to realize it ain't always going to work. There's a better way to look at things. All right, in case you don't remember this, so please, dear God, I'm going to show you why FOIL works. I'm not going to show you the way to do this problem. I'm going to show you why FOIL works. You guys understand? So don't in the middle of this go, why are you doing it like that? Just hold up. So before we do this problem, what if I put a 5 here instead? How would that work, of course?
Yeah.
I do that times x, and then that times 7, right? So I get 5x minus 35. How we do it?
Good.
That's easy. That's distributive property. Does anybody realize that's exactly what this is? What's in front of the x minus 7?
1.
X plus 3.
Oh.
So what am I going to do with the x plus 3? I'm going to distribute it. And again, please, dear God, this is not how I want you to do this. This is why FOIL works. So I'm not saying I don't want you to do FOIL. I'm just showing you why it works. You see, I have to continue to remind you. So I would say x plus 3 times x minus x plus 3 times 7. How are we doing, you guys? With me so far? Isn't that the same thing?
Yes.
Same thing. It's just here it was a 5. What's in front here? X plus 3. Now again, I'm not showing you how to do the problem. I don't want you to do it like this. I'm showing you why FOIL works. So if you know FOIL, that's great. If you don't know why it works, that's not good. That is not good. Now, what do I do here?
Multiplication.
Yeah, distribute. So that would be
2x
x squared.
plus 3x.
Now here, to be a little careful, that 7, it's weird back there. Couldn't I put it up here?
Yeah.
All right, let me rewrite this as minus 7. So then it looks a little... Right, I got to distribute the 7 and the freaking negative. Let me just put them together. Is that cool? Just write it better. And then you bring a negative 7 in, right? Minus 7x minus
21.
21. All right. So let's look back and see a shortcut to this, because this is applying distributive property directly that we know works. Now we're going to look at the pattern and make a shortcut, which is what FOIL is. FOIL is a shortcut to what we just did. And of course, I mean, you can put the two middle terms together, right? What would you get?
Negative 4x.
So what ends up happening is this x gets a turn to go through, and the 7 gets a turn to go through. So really, the shortcut then is each piece of this gets to go in. So there's my x squared, right? Let me go here. Here's my minus 7x. Here's my 3x. And here's my minus 21. FOIL is so unnecessary. And I'm not saying you don't use it anymore if you like it, but I really want you to understand how FOIL is totally unnecessary. What do? Distribute the x, distribute the 3. That's what you do. You don't need FOIL. What does FOIL mean? First, outer, inner, last. It's crap. When you do x times x, distribute the x. You're doing the first two things. Ooh. Distribute the x to the other piece. Okay, you're doing the outer two things. You don't need FOIL, but again, if you like it, it's fine. I'm not taking it away from you. Showing you how we didn't even need to teach it to you in the first place. It's like extra shit you don't need. Yeah. Well, no. FOIL won't work when there's more terms because there's too many terms. There's more than 4 things you can put together. But what I just did still works. All right, let's build our way up. All right, so let me take this away because again, let me get this out of your sight, because this is not the way you do it. This is why it works. So let's do another problem. So now using the shortcut. What would I do there?
2x by this 3.
Yeah. 2x gets a turn, so the 2x goes through. 2x times 3x.
6x squared.
Good. And then 2x times 1.
2x plus 1.
How are we doing so far? It's just distributing, but instead of having like 1 3 in front, I have a 2x and a negative 3. So that each piece gets a turn to distribute. That's all it is distribution. And then
Minus
3
9,
gets a turn. Yeah, minus 9x.
Minus 3.
And that is first, outer, inner, last. Do they even have to think of it that way? No, it's better not to. It's just distribution. Again, I'm not taking your foil away. You can use the foil. And then what's the last thing I could do here? Yeah, what are my like terms? Yeah, these guys. 6x squared minus 7x minus 3. All right.
Why do we have 2x? Can we do 2x times 3x? And negative 3 times 1?
We did. There's 2x times 3x. There's negative 3 times 1. I don't understand. But you can't only do that. You can't only do that because then you're missing these guys.
Yeah.
And then you're completely wrong. So does everybody get that? Because I do get sometimes, I get people tell me the answer is 6x squared minus 3. But then why didn't the 2x get to go to that? Why didn't the negative 3 get to go to that? I mean, you've got to do these cross terms also. Maybe. I can't read you guys. Some of you guys are like, I know this shit. What the hell? I think some of you guys look like you want to hurt me. That's normal. So watch this. Here we go. You ready? Foil would completely abandon you. Foil would go, oh shit. So now it would have to be first middle, first last. That's why I was saying it would be fifth minute. It's a very easy mnemonic device. It's fifth minute. Screw that. So what I do is I say this x gets a turn, and then the 2 gets a turn. It's easy. Then I don't care how. I could put 80 terms in there, which I won't, because then the test would have to be this way. Busy one. But do you understand? I put 80 terms in there. It's the same. I just do the same way. It's just more shit to write. So x gets a turn to go through. What's x times x squared? X cubed. X times negative 2x. Negative 2x squared. X times 4. 4x. Now the 2 gets a turn.
2x squared.
2x squared.
Minus 4x.
Minus 4x. Plus 8. Now, to be honest, I constructed this to do something interesting. It's not always going to happen. Well, what just happens to happen here? I like this. The negative 2x squared and the 2x squared cancels. 4x and the minus 4x cancels. So it's x cubed plus 8. Some of you guys might even realize that that is something called sum of cubes. Not son of Sam, but sum of cubes. What's 8? 2 cubed. What's x cubed? X cubed. So isn't this a sum of cubes? 8's a cube, right? X cubed is a cube, right? So isn't this a sum of cubes? Don't make more out of that than it is. Say again? Because what cubed is 8? 2. The same way I'd say 16 is a square, wouldn't I? Because 4 squared is 16. Is 17 a square? No. Is 9 a cube? No. But it is a square. Yeah. But FOIL is the same thing as distribution. It's just easier to realize, because I already know distribution. Why learn something new when I already know what to do? I just distribute each thing. So everything in this guy gets a turn to go through. How we doing?
Good.
We got more people. So if you want to call this FOIL, I'm okay with that. It's the idea of FOIL. This ain't FOIL, because there's more than 4 things up there, but it's the idea of FOIL. All right.
Does it matter how many like terms I have in each side?
How do you mean? Well, watch this. Okay, I think I know what you mean, and this is what I was going to do next. X plus y minus 2, 2x minus y plus 3. Do that. I'll give you a minute. I sort of feel like Yoda trying to get Luke to rise to the race. Doesn't matter how big it is. You just do the same. You just do it. It doesn't matter how much stuff is in there. You just do the same thing. I'm not trying to say that I'm a Jedi Master. I'm not trying to say that. I wish I was. I am green because today is what? The girl is not green.
St.
St. Patrick's Day.
I don't know if it was the time to
Say that you have green, little tiny socks, no? You got green on your toes. That's probably supposed to be that check.
Yeah.
Say hi.
Say hi.
Huh?
Say hi.
Say hi.
Yeah.
You gotta excuse my Americanization. I like to kill foreign words. For sandwich. Alright. You guys should be close to them. You start to catch up to you. I mean, there's a couple variables in here, right? So you should expect it to not maybe have a lot of, or possibly any. It's going to be a few like terms, but not a lot. What do I get? Now the x gets a turn. So forget these guys for right now. So x times 2x.
2x squared.
X times negative y.
xy. And
Negative
minus,
xy.
Yeah, xy. And
X times 3.
3x.
3x. All right, so the x is done. Then the y gets a turn. So
Plus.
y times 2x.
2xy.
Y times negative y.
0.
No.
No.
Multiply.
Multiply.
Negative y squared.
Oh,
Multiply.
Yeah.
And y times 3.
3y.
Alright. And then the negative 2 gets a turn.
Negative 4x.
I'm going to put it down here. So negative 4x. You see what I did right there? You could actually do that always. Line up your like terms. You know. I just ran out of room, so I got to. Where am I? Oh, yeah, negative 2 times negative y plus 2y. There, see? Do you guys see what I'm doing there?
Yeah.
And then negative 2 times 3, negative 6. I like it. So let's see what we got. Any more x squares? No. Any more xy's?
Yes.
Yes. So I got negative 1 xy plus 2 xy is xy. I like it. And then here I get negative x. I like it. I've already done the xy's. Negative y squared. There's no other y squares, right? Woo! Sorry. So again, I mean, this is not a difficult problem because it has a lot of parts. It is a bookkeeping problem, right? Some of us that are not all that neat will have trouble on these. It's just keeping track of what's going on. Exactly. You know yourself. So force yourself to do things that keep things organized. So I could have, as I went through with this guy, I could have lined up the XYs and so forth. That would make it really nice. That would really keep it organized so you don't miss any like terms. You can just line them up as you do the next guy, line up the like terms. If there aren't any like terms, you put it off to the side. Does that kind of make sense? So do you understand? I'm not going to do this, but I could put 7 terms in here and 8 terms in there, and you would just take each of the 7 terms and take it to each of the 8 terms, and they would each get a term. And then you would get all your like terms together. The process doesn't care what's in there or how much is in there. I just apply it. And all right, let me see. This might not be the best way. Let me go back to this guy real quick. I like to do this a lot. This was done, right? This is done. I'm going to put something on top of this. It's just like a way to check it in a way, to be honest. What is x? I don't know. It could be anything, right? All right, so give me a number for x.
3, 4.
All right, I'll average those. Let's say 2. So now watch this. It's not, again, that problem is done. I don't think the book is ever going to ask you to do what I'm about to do. I just want to show you something kind of neat. So if x is 2, what number is this?
4.
4. And what happens in here? I get 2 squared,
16.
4, minus 2 times 2,
4.
plus 4. 4 minus 4 plus 4 is
4.
4. All right, let me stop there. It would be, if x is 2, is x 2? I don't know. I could let x be 3. I could let x be 7.7, whatever. And so I get from here, I get 16. Now, this being the answer means that I'm saying that these two are the same, aren't? Isn't that what I'm saying? So if x is 2, this better be the same damn thing as this. And sure enough, if x is 2, what's 2 cubed?
8.
Plus 8 is?
16.
Holy shit.
Huh.
Right? So when you do this, when you simplify, you are claiming that this is the same as that. So if you have time or want to, a way to check your work is let x be something and it better come out to be the same damn number or else these aren't the same. So this is sort of a, when I know what the numbers are, of course I can multiply them. Easy. So this process is a way of, when I don't know what the numbers are, I need a way around that. I need a way to still do something with it. And that's really all this process is. If I don't know what parts of the numbers are, I need to have some way around that. And that's how you do it, officially, so that it stays true. Okay.
Okay, it's x not 2, maybe 5, 6.
Yeah,
So
you
it will
could,
be
any number you
right?
pick for this,
So it will be
everything we just did will work the same way.
If your answer is right, it's going to be so.
Yeah, if your answer's right, it doesn't